Hello everyone, this is Btec talking and we are back with another video on Btec FreshAir. In this video, we are going to model and analyze distribution of COVID particles in a room with one COVID positive person shown with red color and two COVID negative people shown with green color. There is one blue inlet and one yellow outlet channels for FreshAir in this specific case. At first, we need to insert geometrical parameters of the room, followed by the location of airflow channels and the airflow rate at the inlet outlet section. Then, we add objects including people and furniture. Finally, exact location and orientation of each person and each piece of furniture is fixed within the room. Note that this section, if you remember, is described in details in the previous video, so we can pass on it here very quickly. Once done, we can review what we have added. As we can see, so far so good, and we are great to go. Once we hit the run button, it only takes 2 minutes for the simulation to finish, which is pretty fast. In the results sections, once we're done, we can observe contours of different parameters, streamlines, and parameters like ACH and pressure drop. Here we see the contours of mean age of air, or let's call it MAA. Moving this slide bar on the left up and down, we can see mean age of air at different cross sections of the room. By choosing streamlines, on the other hand, we can see airflow movement from inlet to outlet, which is pretty cool. Also, COVID contour provides us with concentration of COVID particles around different people. It is recommended to use the logarithmic scale for better visualization of the results. We can see that the concentration is much higher around the sick person. To better analyze the concentration of COVID particles around healthy people, on the other hand, we can change the scale back to linear. We need to also change the range using the legend min-max on top. It seems like 0 to 150 would work in this case. Based on the literature and this distribution, the person standing to the right of the sick person will catch COVID within 15 minutes. Another interesting feature of Btec FreshAir software is capability of tracking COVID particles generated by the sick person, and this is done using COVID streamlines. Using the current air conditioning system, we see that COVID particles generated by the sick person directly move towards the outlet, which is good. Note that dispersion of COVID particles in the room are mostly caused by molecular movements. This was only one case, and we can model other case scenarios. As an example, we can cut the ACH by half, and we did it, and we ran the simulations twice, and as you can see on the right side, the concentration of COVID particles for the case with lower ACH is much higher, and both healthy people can catch the virus within 15 minutes. We can also model different case scenarios using this software. Thank you very much for watching this video.